Euler diagrams are not horrible, they're funny. So an Euler diagram is a Venn diagram where all bubbles are disjoint. Yeah, it's just a bunch of circles. They're not allowed to overlap. Okay? The joke about this is this. So here's a Venn diagram, right, of the Venn diagrams. These ones in here are Euler diagrams. And this diagram is right there. See, wasn't that fun? It's an Euler diagram. No. So Euler diagrams are not specifically useful. They're just kind of a funny example of a really specific kind of Venn diagram. These things happen with numbers, like the kind of maybe more classic number example is this one. Maybe let me do this. So we have all the real numbers, right? And those are broken into two kinds. The two kinds are
Positive and negative?
flat, not flat. Positive. Yes, positive and negative would be two valid splits, not the ones I'm talking about.
Rational and irrational.
Okay, and then in the rational numbers,
We have the whole numbers. Oh no, the integers. I don't know what comes next. I don't know the order.
yeah, okay, so I think integers is usually the next level.
Okay.
And then there's whole numbers. And then there's natural numbers. And this thing is this is an Euler diagram, right? Because it's just kind of continually refined. If I put positive and negative in here, I would no longer have an Euler diagram. You guys see that?
Oh, so disjoint means like they're all like within each other, like they're.
Yeah, sorry. There are no overlaps that aren't entire.
Okay.
Your colors don't mix.
Yeah, I did say disjoint, and disjoint is not actually quite right.
I thought it was like where they
They're
don't
definitely not.
touch at all, so I got really confused.
Yeah, I'm sorry. You're right.
Maybe you should.
What do I even mean by this?
Are contained fully within a larger bubble?
Yeah, that's a much better phrasing. Okay.
So if you threw it up some irrational number sets, it wouldn't be a Euler diagram.
They're still contained entirely within any larger bubbles that they're contained in, right? So, for instance, of the irrational numbers, there's a split called the Bruno numbers, for instance. There's the I hesitate to say that, so maybe I won't. That's a condition that's probably not in evidence.
Where would the transcendentals go in that irrational?
This is the number theory thing. I'm not sure that they don't overlap with the Bruno numbers a little bit right off the top of my head. I suspect they don't. And that would ruin my Eulerness, right? But not my Vennness. So if I wanted to do something like add the positive negative split to this thing, how would I do that? Okay, irrational numbers, do they come in positive and negative? Yes, I'm going to tell you the Bruno numbers come in positive and negative. Do the rationals come in both positive and negative?
Yeah.
Do the integers? Yeah. Do the whole numbers?
Yeah.
What is the whole
If
numbers?
if you include negative 0, which is.
Yeah, I'm not sure whether we should include 0 or not.
0
Let's put 0 on the positive side. Then I think the whole numbers aren't containing any positive, or only containing positive numbers. They don't contain any negative.
I thought that was natural numbers.
No.
It depends on where you put 0.
Don't include 0.
Do you call 0 positive or negative? Or both? If you call 0 both,
Then you have
then
more.
you have some weirdness. Yeah. I'm going to go like this. Shit. I labeled the wrong side. You're kind of with this?
That's no longer Euler.
Yeah, and this fails to be an Euler diagram now because I have this kind of funky list ones in both pieces. What's that?
That's how it's spelled, though. It's the name of the dude.
Yeah.
No,
Sorry.
I believe you, it's just, it's such an opposite word. How do you spell it?
Why would distract me?
It's German.
Yeah, come on, keep
That should
distraction.
be on the test. How do you spell
Okay.
But how would you put that in your test?
Well,
What
you
type
just
of
ask,
diagram?
and then if you think about it, you just read.
Yeah, it's like what color is the white horse?
Spell it using the International Phonetic.
Any questions on this idea?
What's the point
What's the point?
of this?
Good, what's the point? So why would I do this with data? To visualize the data. So I can get the size of the overlaps.
But there are no overlaps.
Yeah, so the Euler ones are not specific, are not super useful, except that you can see which things are contained in what. Right, so like, maybe I did one with shapes. So there's like polygons, right? And then someplace in here there's a set that's 4-sided polygons. And then in there there's rectangles. And then in there are squares.
Why would the square be inside the rectangle? Just because it's smaller?
Because
All squares are rectangles, but not all rectangles are squares.
a rectangle's a specific, so a rectangle's a 4-sided shape, right? With right angles and
They're all the same.
2 sides, like opposite sides of the same line, right? A square
This is all the
is a 4-sided shape, straight edges, right? Right angles, and 4 sides that are all the same. That meets this criteria. Right, if 4 right angles and opposite sides are the same way. So a square is a kind of rectangle.